Okay, welcome back. So now we get to do some factoring, finally. Again, let's examine exactly what's happening when we expand something. I'm going to create a new question again. We've seen this question. It is x squared plus 7x plus 12. I know that that factors down to x plus 4, x plus 3. And you should know that we can expand that to go back up to it. Let's take a look at what it looks like expanding. X times x is x squared. X times 3 is 3x. 4 times x is 4x. 4 times 3 is 12. But I'm going to write it like this. Let's notice something here. These two numbers can be found because these two numbers multiply to give 12. And these two numbers add to give 7. So to get these numbers, what we want to do is we want to find two numbers that multiply to give 12 and add to give 7. Those numbers are 4 and 3, and there they are there. So the only thing we have to really know is that to be able to get the x squared, we have to start off with two binomials in that form. This is exciting. I'm excited. I hope you're excited. Let's go. X squared plus 7x plus 10. So I know the answer is going to look like this. It's got to be two binomials. I know I'm looking for two numbers that multiply to give 10, add to give 7. Those numbers are 2 and 5. 2 times 5 is 10. 2 plus 5 is 7. So plus 2, plus 5, and we're good to go. We could also write that as x plus 5 and x plus 2. And that is awesome too. So both work. Okay, so on to the next example. Negative 28. So I'm looking for two numbers that are going to multiply to negative 28, but they're going to add to 3. All right, so maybe you know them and maybe you don't. I'm going to use a factor tree. Get my 28 over. I don't really care about the negative at this point. I just want the factors. 1 and 28, 2 and 14. 3 does not go evenly. 28 divided by 3, nuh-uh. 4 and 7. 5, nuh-uh. 6, maybe. 28 divided by 6, nuh-uh. 7 and 4. Ooh, look, I get to stop. So, which ones of these pairs will add to 3? 4 and 7, 4 and 7. All right, 4 and 7. Now, they have to multiply to give a negative, which means one's got to be negative. How am I going to get a negative, if one's negative, and still get a positive 3? Well, how about if the 4 is negative? Oh, okay. So, 7 times negative 4 is negative 28, and negative 4 plus 7 is 3. Oh, my goodness. X minus 4, x plus 7. Let's see if it's right. X times x is x squared. X times 7 is 7x. Take away 4x is 3x. Negative 28. Fiesta trio. We are correct. Okay, next one. 28. So you want two numbers that multiply to give 28 and add to give 11. I don't know my times tables. Let's go and do it again. 28. 1 and 28. 2 and 14, 3 doesn't go evenly, 4 and 7, and then 5 doesn't go evenly, 6 doesn't go evenly, 7 and 4. Which one of these will go together to give me 11? 4 and 7 again. The only difference is they're both positive this time, so that they add to give me 11, but multiply to give me 28. So, x plus 4, x plus 7, x times x is x squared. 7x plus 4x is 11x plus 28. Life is grand. We are correct. Okay, negative 30. Two numbers that multiply to give negative 30 and 7. How do you feel about 15 and 2 won't work. How do you feel about 6 and 5? 6 and 5, okay. If I can't find it in 30 seconds, I'm going to my factor tree. 1 and 30, 2 and 15, that doesn't add to 7. That won't add to 7. 3 and 10, woohoo! That'll add to 7. Let's stop there. That's good enough. So 3 and 10 have to multiply to a negative. One positive, one's negative. Have to have positives left over, so it better be -3. Let's see if it works. Yep, 7. Yep. Wow. Remember how hard this was in grade 10? Thank goodness it's grade 11. It's easier now. Perfect. No part marks for these, by the way. They're either right or they're wrong. That's it. Nothing in between. Okay, bracket. Bracket. Let's find my numbers. Two numbers that multiply to give 12. Add to -13. How about -1 and -12? They multiply to give positive. They add to give that. Life is grand. And I'm done. Question 2. Let's finish question 3 so I can post this video and you can start your homework. Okay, so we want the area of a square that's given by this. So we have a square, which means that the sides are all equal length, and the entire area is given by a trinomial. We would like to know what the area is in factored form, because that way I can determine a length and a width. Now in this particular case, they're both going to be the same because it is, once again, a square. So, two numbers that multiply to 100, add to give -20. I might be faster than you. You might have to stop and go over it. That's life. You're fine. Make sure you do. And look what we got. So this is length, this is width. So therefore, the length is given by x minus, well, why don't we say the length is given by length equals x minus 10, and you should always put in units because it's going to be measured in something. And that's it. So you are now going to work on this sheet, which is kind of fun. Okay? You're going to do the diamond math problem, which is kind of fun. And on the back you have all the answers. And I'm going to post some work from the textbook, and we'll meet back and do the next graphing y-intercepts and x-intercepts investigation in a little bit.